All right, we're ready to begin our fifth algebra review set of notes here. And in this video, we're going to be reviewing variable expressions and combining like terms. So at the end of the video and at the end of the notes, you should be able to write algebraic expressions from words and also identify and combine like terms in algebraic expressions. So let's begin by taking a look at 9x squared minus 10x plus 4 that I have written at the top of this screen. I'd like to pick it apart a little bit just for a moment. The number that sits in front here, we're going to refer to that as a coefficient. And of course you've heard this term before, but we want to be clear on what it really means. We also have variables. The letter X is a variable, something that we don't know, but it's being represented by that letter. And then we also have something called a constant. So a constant doesn't have a variable with it. And the entire thing here is called an expression. So an expression just has terms. It could have one term, two terms, three terms. And if we really wanted to think about what a term is one individual piece of this expression. So there's one term, two terms, three terms, and you can count the terms by the operations here. So every time there's an operation, a term is separated, while the operation symbol separates the different terms. So in this case, we have three terms, one here that says x squared, two here that says just the x, and then the third one is just a constant term. So these are the things that are important for us to know as we move forward in this lesson. So taking a look at the formal definition of expression, this is any numeric or algebraic phrase that has no equal sign. If you take a look at the one that I've written at the top there, there's no equal sign. This is just a phrase. We can combine like things to simplify it, but we cannot solve an expression. An expression is not something that we want to end up with, x equals something. That's not our objective with expressions. We're just going to be combining like things. So if I give you an example here, an expression could be a single number, or it could be two numbers that we want to add together. This is an expression, 2 plus 8. We could also have an expression, 7x plus 5. Like I said, these things are not alike, so we're not combining them in any way, but we're just going to leave it, that's an expression. Here's another example of an expression. And finally, if we have this expression, x squared minus 7x plus 5, that is also an expression. None of that can be combined. That's really its final form. We're also not trying to solve it. Okay, so we want to know the difference between an expression and an equation. If I give you an equation would look something like this, 7x equals 14. Now that you could actually solve. This is an equation because it has an equal sign. Okay, and like we said about expressions have no equal sign. Our next vocabulary term is variable term. Variable just means that it changes. It could change, it varies. A symbol, this is a symbol of some sort that's usually a letter used to represent an unknown value. Okay, so we could use the letter X, we could use the letter Z, we could use the letter Y, and you might have seen it, so many different ways. Generally, in algebra, we use X, Y, and Z quite often because other letters are designated for other things, but any letter or any symbol, I guess, for smaller children, people use different symbols like, symbols, literally symbols, but in our case, we're going to be using letters to represent variables. And of course, we could have a coefficient in front of that variable. So 1/2 x could be a variable term. 3x squared could be a variable term. So just recognize that there could be a coefficient in front of the variable, but we would still consider it a variable term because it has a variable in it. Continuing on, we have the vocabulary term constant term, a numeric value that does not change. Okay, it doesn't change because it does not have a variable next to it. The only things that will vary in your expression or in your equation are things that the terms that have a variable. So a constant term could be 4, if we add that at the end. A constant term could be not the 2x part, but definitely the 7. Okay, notice that the 7 doesn't have a variable next to it. And then, of course, if you see something like this, well, which one of these is a constant term? It's the one with no variable. All right, last, I did mention the word coefficient already, but let's just review a number in front of a variable that gets multiplied by the variable. So, for instance, 2x plus 7, the 7 is the constant, but in this case the 2 is the coefficient. It's the number that is sitting next to the variable that will be multiplied by it. Okay, another example, 3x squared minus 14. Here's our coefficient. And then just one more example. Here's a coefficient for this term because it's sitting in front of the variable. Then we have this coefficient sitting in front of the x term. And then, of course, the plus 2 is just a constant because there is no variable next to that one. Okay, so you should be familiar with the terms expression, variable term, constant term, and coefficient. So we're going to go ahead and try to write some algebraic expressions from words. So if we look at each English phrase, we need to be able to write a variable expression. So if we have a variable in it, it should have some letter, and you can use a letter that kind of makes sense for that particular problem or that particular phrase. We want to recognize the different words that we see here too. The difference of 10 and a number. Okay, difference means subtract. And because we're subtracting 10 and a number, well, then that means that we would have 10 minus, I'm going to say the letter n because n is representing the word number. So the difference of 10 and a number, so I'm going to just subtract those two. The next one says the product of 7 and x, or the product of x and 7. Product means multiply. So it's important that we recognize what these words actually mean in math language. And so if we're going to multiply the product of 7 and x, I just have to write 7x, because we all understand that there really is a mathematical dot there, but we just don't put it in there. So we don't usually write 7 times x like this, or 7 dot x, but that's really what's meant. So 7x is good enough for that one. The quotient of the square, okay, so the square, we have to know what that means, of a number, and the cube of a number. Well, quotient means divide. Okay, so you could write the divide symbol, but more likely you're going to see this as a fraction, because a fraction is really a quotient. It's a division problem. So it says the quotient of the square of a number, okay, so I'm just going to use x here, the square of a number, and the cube of a number. The cube means that it's to the third power. Okay, so third power is cube, square is second power. So here's our answer for part C. And for part D, it's asking us to give 5 more, so write a phrase that's 5 more than the sum of twice a number. 5 more, which means to add 5, than the sum of twice a number. Twice a number is 2 times some number. We'll say it's x, some number x, and a different number. Okay, so now we're saying a different number, which means we actually have to bring in a different variable to represent that different number. So I'm just going to use y. So we have to say that these things are going to be together. There's the sum of twice a number and a different number. Okay, so the sum means that we're adding. And then we have to do 5 more than that after that. So in parentheses, I'm going to have 2x because I have to do the sum of twice a number and a different number. And then I'm going to add 5 onto that. Now it does take a little bit of time to dig all of this out of the phrase, so please take your time in doing that. Don't just skip these problems, give it an effort. You know, there's some problems below here that I'd like you to try, and Actually, it's on the next page. I do apologize, but on the next page, please try those practice problems and don't give up. Persevere a little bit here. Okay, I hope you tried those problems, and let's move on to the second part of these notes, which is going to be combining like terms. As you see, there are 5 important ideas when it comes to combining like terms, so it is important for us to both be able to simplify and solve, and so in order to do that, we need to be able to combine like terms. And by combining like terms, we simply mean to add or subtract similar terms. So we're going to keep together constant terms, things that don't have variables. We're going to keep together variable terms that do have variables. So these are 2 separate things that we need to be able to combine and follow some specific rules about that. So right here it tells us that constants, ones without variables, those can always be combined. Okay, so let's take a look at 7 minus 6. That's just 1 minus 4. 1 minus 4 is negative 3 plus 2. So negative 3 plus 2 is just negative 1. So I've combined all my constant terms together, nothing else to do there. Next, I have variable terms. Well, what can I do with variable terms? They must all have the exact same letters if I'm going to combine them, and they have to be in the same order in order to add or subtract them. So there are a couple of examples here. It looks to me like we have a negative x and a positive x. Okay, they're the same number of letters in that particular term, and we can just add them together. And we know that if there's a positive and a negative of the same sort, there's nothing left. So the only thing that is left is this y here and this y here. And how many y's do we have? We have 2y. All right, the next example, there's an xy I see there, and then I see also a yx. Well, we know that anytime we multiply, because we just did this in our last lesson, if I multiply 2 times 3, or if I multiply 3 times 2, I still get 6. So because these are in different orders, that doesn't mean they are different terms. They're actually the same thing. So I could rewrite this so that it looks the same with the variables in the same order. And now, if I look a little bit more closely, I see that there's a yz, and here's another yz, but this one happens to be positive. So in my quest of combining as much as I can, I'm going to go ahead and get rid of that and that. And remember, now I have this term and this term, which actually is just 2 of those, so I can write the number 2, which is going to be my coefficient, out front. And now I can also subtract the one term that I really don't have anything to combine with. Okay, and so here's my final answer, and that is a z, by the way, not a 2. So our final answer is 2xy minus zx. The next rule we have here is that variables and constants cannot be added and subtracted together. Okay, so if I'm looking carefully at what I have, this expression here, there's no equal sign, so we know it's an expression. This term has a variable and this term has a variable. The other two are not variable terms. Okay, so I have to be very careful to only combine the things that are alike. 40 plus 2 is 42, and we have a negative d here and a negative d here, which is actually 2 d's, and they're both negative. Now, when we write expressions, we want to get used to writing the term with the variable first. So I'm going to put my negative 2d first, and my constant term will be last. Okay, so that's how I can combine that. Our fourth rule of combining like terms says that we can add and subtract variable expressions with exponents, but we have to be really careful here. The exponents must be the same also. Okay, so take a look at the exponents. We have an exponent of 3 here, an exponent of 3 in this one. So we could probably combine those two right away. So let's do that. If we have an x to the third and x to the third, that's 2x to the third because there's 2 of them. And it looks to me like we also have this term here with a 2. as its exponent, and this term here is with a 2, so we can combine those two because the variable is the same and the exponent is the same. So now I can say I have two of those terms, so that's going to be 2y squared. And then the only thing that isn't combinable with anything else is this negative x to the fourth. So I'm going to put that out here. Now the other thing that I want to remind you guys of, if you haven't already done this in the past, when you're looking for things to combine, or actually at the very end, not just to combine, but to finalize your answer, there's a couple things you want to keep in mind. You want to keep in mind that the largest exponent is going to be written in the first term. So 4 is our biggest exponent, then the next largest, then the least largest exponent. So that's why we have descending exponents, 4, then 3, then 2. Okay, and finally here we have to combine terms but only add the coefficients. So adding the coefficients means that we're looking at the number in front of the term, and first we have to see, can we even combine anything together? Well, I see a lot of exponents, so first I want to notice there's one with exponent of 3 and exponent of 3, so I can combine those. So what is it that I'm combining? I'm taking the 4 and the 3 and I'm combining that. Okay, so I'm going to have 7x to the third, just pulling those things out. Okay, then I'm going to cancel, cross them off so I don't rewrite them again. So I have 7x to the third. I also have a couple of terms here that don't have any variables, so those are my constant term. So here's a 10, here's a negative 20 and 10. That's going to end up being just negative 10. Okay, that's again, I'm just crossing off so I can see what I have left. And I do have a negative 2x to the fourth. Nothing else here has a exponent of 4. So I'm going to put that out front. And then I have a negative y squared. I'm going to fit that right in here because my exponent is 2. The 7x was a positive 7x. So basically I kind of pieced it all together, and my final answer is right here. Again, my exponent should be descending. My variables, though, notice that my variable x, the two terms that I have a variable of x, oh, I think I should rewrite this. I'm glad I caught that. 7x to the third should go first because the 3 is the biggest, minus 2x squared. And then I'm going to put my y term because my variables should go in alphabetic order. Okay. And now I have my final answer because I wanted to switch my exponents around. Okay, I'm going to try 4 examples with you if you take a look at example 2, and then I'm going to leave you to finish up those last 5. And of course, if you find some questions that you've come across over the time that you've been watching the video, please write some questions on the edge of your paper. If something isn't making sense, please be ready in class to ask questions so that you can get your questions answered. That's the benefit of watching the notes at home, the video at home, is that you can slow it down if you need to or speed it up if you're already familiar with some of the things we're talking about, but you should be asking the questions that you need to in class. I want to encourage you to do that. All right, so for part A, we have 4 terms, okay? So 1, 2, 3, 4 terms, and we want to combine the things that are alike. What is alike? Well, I have a variable term here and a variable term here. Remember, variables are the letters that represent unknowns. And then we have a negative 10 and a negative 3, which are constants. My negative 10 and negative 3 come out to negative 13. You can feel free to use a calculator here. 9n and n. Well, this has just got a 1 in front of it. So we have 10n minus 13 as our final answer. Let's move on to B. B just has 2 terms, the negative r and the negative 10r. Those both have a variable with them, so we're adding together the coefficients. The coefficient of the first term has a 1. I know you can't see it, but that 1 fits right there. So we have negative 1r, and it's going to be basically adding negative 10r if we were to rewrite that in a different form. So negative 1 and negative 10 is negative 11r. So we're combining them, and we just end up with 1 term. For problem number C, or problem letter C, we're looking at the exponents, there's a 3, a 3, a 3, and this 4 doesn't really fit with anything else. So we know we're going to start with that term because it's the largest exponent as well. The other terms all have x to the third as the variable and exponent, so we can combine them. But if you look carefully, all of our coefficients are fractional. And so that's going to provide an opportunity for us to do a little bit of extra work. And we're going to need to do that right here. So negative 2/5 actually converts to negative 8/20. How did I pick 20ths? Well, the 5 and the 4 both go into 20, so we have to find a common denominator for adding fractions together. And then we also have negative 3/4, which ends up being negative 15/20 after I do the work. I'm going through this sort of quickly, but you get the idea that fractions have to be, have to have that common denominator when you're getting ready to add the coefficients. And then, of course, 1/4 converts to 5/20. So if I'm looking at this and I rewrite it, I'm going to say that I have actually a coefficient of 8/20, x to the third. I also have negative 15/20, x to the third. And then I also have 5/20, x to the third. And then I get to combine them all. Well, it looks like I have two negative coefficients there. And then I end up with the positive 5 here. So I'm going to finish with x to the fourth minus 18/20 x to the third. And I think that's it, because I was able to combine all of my coefficients, 8/20, 15/20, and 5/20. Okay, folks, let's do one more problem. I just want to mention that we want to look carefully at the terms. This one has an xy, this one has an xy, and as you know, there's a 1 in front of there. It's not showing up, but you know that it's there. And then we have a coefficient of 3 for this term and a coefficient for 6 for this term. And this term says x squared y, this term has x squared y. So remember, you have to combine things that are alike. This term is alike because it has the same set of variables, the same exponent, etc. So now I can just add those coefficients together, 9x squared y. And I can also take this term, the 1xy and the 10xy, and combine those together, and that is just 11xy. So take your time when you're practicing these. Check and see if the exponents are the same. Check and see that the variable order is the same, and then add the coefficients together. So I hope this has been helpful. And again, if you have questions, please write them down so that you can ask when you get to class.